Hey, how's it going guys? Welcome to another Excel tutorial video. My name is Jay. In this tutorial, we're going to learn how to build a simple loan calculator application in Excel. So if you ever want to take out a car loan or mortgage from a bank, it's always good to figure out how much interest payment you'll be paying as well as what's the total payment monthly. And there are many loan calculators online today, but unfortunately, most of them give you little to none customization and visualization. So today, we're going to build a loan calculator in Excel with payments breakdown as well as a bar chart that will visually presenting the principal as well as the interest payment that you have been paying throughout each year. So before we get started, let's take a look at the calculator that we'll be creating in today's exercise. So here's the loan calculator. And this calculator is breaking down into 4 different sections. So here we have the loan detail section, which is your input fields, and the loan summary, which is your formula field. And on the bottom is your monthly payment breakdown table. So here, from this table, we can see that for each payment, we have the payment dates, payment number, the beginning balance before you make the payments, and the ending balance after you make the payment, and the payment amount, the principal amount that goes towards paying off your loan amount, as well as the interest amounts that you're actually paying to a bank or whoever is loaning you the money. And lastly, we have this stack bar graph that will show you up to each year how much total principal as well as the interest amount that you have been paying up till that year. And so in here we have the line graph that is showing you the ending balance throughout each year. And before we get started, you can download this Excel template via the link in the description below if you want to follow along. So if you download the Excel template, this is probably what you're going to see. So the template has a header, the loan summary sections, which we haven't populated the formula yet, and the payment breakdown table. And we're missing the chart. So we're going to build everything from scratch. So first, we're going to create a list of name ranges. So we're going to create the name range for all our input fields. So here I'm going to select my loan amount, and under the cell reference box, I'm going to name this cell to loan amount. And actually, let me make let me zoom in a little bit more so that way you can see it better. And for the annual interest rate cell, so I'm going to name that as interest rate. And for the loan period in years, I'm going to name that as loan years. And it's going to be loan start date. Now let's go down to the loan summary. For the first formula, I'm going to enter the formula for number of payments. So the formula for number of payments is basically just the loan period in years times 12. And here let me just populate some dummy data so that way I can validate my number later. So here for the loan amount, I'm going to enter 37,200. And for the annual interest rate, I'm going to use 4.25. And for the loan amount, I'm going to use 6. So let's do 6 years. And the start date of the loan, I'm going to use today's date, which is December 14, 2019. Now next, I'm going to enter the formula for monthly payments. In Excel, there's a function called AIPMT function, which is used to calculate the monthly payment. So here, if we look at the parameters, so the first parameter is the rate, and the rate is taking the annual interest rate and divide by 12. And the NPR parameter is asking for the total number of payments. So here, and here our total number of payment is just the number of payments, which is going to be in cell D12. And I'm going to press F4 to lock the cell reference, and comma, and the PV, which is the present value is going to be a loan amount. And like that. And we need to insert the minus symbol to reverse so to make the number positive. And here we get $586.25. So that's our monthly payment based on this this loan amount, this annual interest rate, and the loan payment years. Now we know the monthly payments and the number of payments, so we can calculate the total cost of loan. And so the formula is basically just the monthly payments times number of payments. And here I should lock the cell reference for both. And we have $42,209.84. So that's the total cost of loan. And to calculate the total interest, so we'll take the total cost of loan and plus F4 to lock the cell reference and subtract the loan amount. So that means based on this list of information, we'll be paying $5,000, almost a little bit more than $5,000 for the total interest over 6 years. Now we're done with the loan summary. Now let's go down to the payments table. So this is the payment breakdown table. And first, we're going to enter the formula to calculate the payment number. So here I'm going to insert if condition. And I'm going to insert sum function followed by rows function. So here I'm going to insert cell reference from B17 to B17. And I'm going to lock just the beginning cell reference. So I'm going to highlight B17 and plus F4 and close parenthesis. And here I'm going to insert greater symbol. I'm going to say that if the total row numbers is greater than number of payments, I'm going to return blank value. And otherwise, I want to get the number counts. So basically, just take this formula. And the beauty with this formula is that, so here let me change the year from 6 to 2. And we have 24 payments total. So if I autofill this formula, and if I exceed 24 payments, so let me go back. And once you reach to payment 24, and the remaining cells or formula is going to return blank. So in a way that it makes the payment number dynamic. So if I change the loan period in years from 2 to 3, so that'll be 36. And the payment number will stop at 36. Now let's enter the formula for payment dates. For payment dates, I'm going to use the date function. And for the year, I'm going to use the year function and to get the year from the loan start date. And same with the months. So I'm going to use the months from the start date of loan. And except that I'm going to add the payment number. And the date value will be the same, so it will be the same date value as the start date of loan. And here I'm going to insert if error function to handle any error that occurs. Now here we get January 14 of 2020. That means our first payment is going to be a month after December 14, 2019. Now let's move on to beginning balance. So to figure out the beginning balance, we can use a function called FV, so which stands for future value. And here the first parameter is the interest rate. So we'll take the annual interest rate and divide by 12. And the NPR, meaning the total number of payments, which is 36. And plus F4 to lock the cell reference. And here we need to subtract the number by 1. And PMT, so payment. So here's my monthly payments. And plus F4 to log the cell reference. And lastly is the PV, so which is a present value, and that'll be a loan amount. And here, my beginning balance is a little bit too high, so let me double check. Oh, so here's my mistake. So this should be B17. So if I autofill this formula, show you loan amounts. And see, so the payment should be minus. So here I'll insert a minus symbol. Okay, and that's the so here's the formula. And I'm going to insert if error function to handle the error. So if there's any error, then I want to return as empty string. To calculate the payments, so actually the formula is pretty easy. So here I'm going to use the len function and to grab the payment number. So here I'm going to say that from cell in column B, if the payment number cell is not empty, then I want to return the payments, so which is going to be in cell D11, and press F4 to lock the cell reference. And otherwise, I want to return as empty string. Oops. So here I forgot the if statement. And here let me change the year to from 3 to 6. Okay. To calculate the principal, I'm going to use a function called AIPMT. So this function will return the payment on the principal for a given investment based on periodic constant payments and the constant interest rate. So if we look at the parameters, my first parameter is the interest rate. So we'll take the annual interest rate divided by 12, and PR meaning your payment number, and D12 is the total number of payments. So make sure that you lock the cell reference for total number of payments, and PV is your loan amount. So we need to inverse the number from minus to positive. So here I'll insert a minus symbol. And also I'm going to insert the if error statements, so to handle any error. To calculate the interest, so here I'm going to use a function called AIPMT, and this function will return the interest payment for given period for an investment based on periodic constant payments and a constant interest rate. So at the end, basically all the payment functions are all very similar. So if we see the rates, so we know it's going to be annual interest rate divided by 12. And PR, so payment number, and this is going to be total number of payments, and PV, so present values, which is the loan amount. And here I'm going to inverse that, so I'm going to insert times -1, or we can insert negative symbol at the, in the beginning. Now the last formula we need to enter is the ending balance, and the formula is super easy. So you just take the beginning balance and subtract the principal amount. So here I'm also going to insert if error statement and autofill the formula. Alright, so here I'm going to take the first, so I'm going to highlight row 17 from cell B17 to age 17. And I'm going to just autofill this formula all the way to maybe to row 198. Okay, so here let me take a look. Oh, so here I made a mistake. So the minus symbol should go in the beginning of the future value function. And same with the interest. Oh, so here I forgot to include the if error function. Now let me try again. So if I highlight B17 to H17 and autofill the formula. And here we have the payment breakdown for each payment date. So we have 72 payments, and the last payments will be paid on December 14, 2015. Alright, now we're almost finished. So the last thing we need to do is we need to insert the chart. So to insert the chart, and here I create a chart data tab, so which is going to be used to store the source data to generate the chart. But first, I'm going to create the chart source table on the same worksheet as the template. And my source data tables is going to have 5 columns. So here the first column will be year number, year, principal, interest, and the ending balance. So year number is pretty easy. So year 1 all the way to year maybe so this should be year 1 plus 1. So year number is going to be based on the number of years that your loan will last. So in general, hopefully your loan doesn't last more than 10 years. But if you're taking out a mortgage, then you can expand the year number to maybe it can be 20 years or 40 years. So depending on the loans that you'll be taking out. And for the year, so here I'm going to use the year function, and I'm going to combine with the max function, and I'm going to figure out the max payment dates in column C, and press F4 to lock the cell reference. And I'm going to insert a condition, so greater or equals to. This should be. So I forgot another close parenthesis. And here I'm going to do a check against the year from the first payment date. And I'm going to press F4 to lock the cell reference. And plus the year number. And -1. And now I'm going to insert my if statement in the beginning. So here's my logical test. If the value returns 2, then I want to return the year. Actually, yeah, so I'll return this. And otherwise, I want to return as empty string. So let me autofill this formula all the way down. So based on this formula, and because I'm actually validating my maximum year, so if the maximum year's value is greater than this output right here, and we know there's no more payment dates beyond that point, so I want to return as empty string. And for the principal amount, so for basically a cumulative throughout each year. Actually, let me do this first. I'm going to format my table because it doesn't look very organized. Okay, I think that looks a little bit more organized. To calculate the principal aggregate principal amount, so here I'm going to use the if condition, and I'm going to say that if M9 is not equals to is not empty, I want to use the SUMIF function to sum my principal, giving a based on certain conditions. So my sum range is going to be the principal column. And my criteria range, or my first criteria range, is going to be payment dates column. And comma. Let me go back. So the criteria is going to be greater or equals to. I'm going to concatenate with the dates function. And my year is going to be year from the year column from my chart source table. And plus F4 to log the cell reference. And it's going to be the first month and the first dates. First day, not first dates, first day. And for criteria range number 2, so it's going to be payment dates again. So payment dates column. And plus F4 to log the cell reference. And except that this time, my criteria 2 is going to be less than or equals to, and concatenate with the dates function again. And this time I'm going to highlight my year cell, which is going to be M9. And it's going to be the last month and the last day. So we know the last month and the last day is going to be December 31st. And close parenthesis. And comma. So here if the logical test returns false, we want to return an A. For the aggregate interest, so here we'll just take the same formula from the principal cell, and except that for the sum range, we'll replace that with the interest column. And lastly, for the ending balance, so here I'm going to insert if condition. So if year value is not empty, then I want to use a function called minIfs function. So let me make that 100%, because it's pretty hard for me to end the formula when I can see the entire table. So let me enter the formula here. So here I'm going to say that if my year value is not empty, then I'm going to use the minIfs function to get the minimum ending balance value, giving a criteria range. So my min range is going to be my ending balance. And my criteria range 1 is going to be my payment dates column. And here my criteria 1 is going to be the same as the principal column and the interest column. And except that for the year, I'm not going to lock the cell reference. And for criteria range 2, so it's going to be payment dates column. And plus F4 to lock the cell reference. And it's going to be greater or equals to, and here I'll grab the date function, and I'll grab the year from M9, and it's going to be December 31st. And if the logical test fails, so I want to return NA. Now let me just format the cell real quick. So I'm going to format the cell as currency and with 0 decimal points. So I'll autofill this formula all the way down. So the reason why I'm using NA to return the value when this logical test fails is because when a chart sees NA, so this, which is this error symbol right here, or this error value, and it's going to ignore the value. But if you just simply leave everything as blank, then Excel grab is going to try to attempt to grab the blank value. And I'm going to go to Insert, and on the chart, so I'm going to use stack column graph, so which is this one right here. And first I'm going to go to Format, and I'm going to remove the border. So on the Format, choose No Outline. And I'm going to expand the chart a little bit. I'm going to delete the chart title. Now select the ending balance bars and right click and select Change Series Chart Type. So we're going to change the ending balance bar from stack column graph to just a regular line graph with markers. And we'll make that a secondary axis. Now we're going to delete the y-axis label for the ending balance. And next we're going to move the legend to the top. So under chart design, and go to add chart element and go to legend. So we're going to move the legend to the top, and I'm going to manually drag this legend to the left. And that's it. So the last step is I'm going to cut and this chart data source table to the chart data tab. And okay, so this one's optional. If you don't like the chart color, so you can go to chart design and you can go to change colors and choose the color that you prefer. I'm going to choose the second item from this colorful palette 2. I'm going to use that color style. And that's it, guys. So this is basically everything. And if I change the loan period in years from 6 to 8, and I'll get 8 different years. And if I change the interest rate from 4.25% to actually to 11%, and so here we'll get pretty big jump. So here, let me adjust the y-axis. So if I click on the y-axis and click on format axis, oops. And for my minimum bounds, so I'm going to set that to 0. Let me change that, so 0. And based on this inflations, so I'll be paying $18,897.93 for the total interest, which is going to be pretty expensive. Now, there's one more thing I want to do. So I want to validate whether or not if this loan calculator application will match to the loan calculator that you use when you want to purchase maybe a car or a house. So I'm going to use Tesla's website for validation. So let's say I want to buy a Tesla, and I know the Model Y is coming out, is going to be produced next year. So here I'm going to Tesla's website. On the Model Y, I'm going to click on order now. And I'm going to choose purchase price. So that's the actual purchase price that you'll be paying. And also I want to get a long range Tesla Y. I'm going to choose red. And the wheels going to be just the aero wheels. And it's going to be a 5-seater. And I want to choose white as my interior. And I also want to include the full self-driving capability. So I'm going to make sure that my option is select. Now if I click on estimate payments at the bottom, if I go to loan, and here I can calculate my monthly interest payment. So let's say I want to put down $20,000 down payment, and based on a 60 months term, so that's 5 years, with an APR of 4.25, and here I get my finance amount of $43,200. So here I'll type in $43,200 and 4.25, and it's gonna be for 6 years. Is it 6 years? Let me check. 5 years. From my loan calculator, it's going to tell me I'll be paying a monthly payment of 848 cents. Now if I go back, so from Tesla's calculator, and my loan payment is going to be $800 per month, which is exactly what we have from our calculator. And if we look at the total interest, so we'll be paying total interest of $4,828.61 based on a 5 years loan with the interest rate of 4.25. Now if we change the terms from 60 months to 72, so that's I think that's 6 years. Yep, 6 years, and we're paying $681 per month. So let's just do a check. 6 years and $680.80 per month. So that round out to $681. So this is everything for this tutorial, and hopefully you guys learned something useful. I'll post the download link to this Excel template file as well as the finalized Excel application, so you can download the files and play around with it. And lastly, thank you guys for watching. I'll see you guys on the next video.